Okay, Trig Kids, I'm probably going to try to break this down into, let's see, I'll try to do 15-minute videos, I think, until we have enough of them to fill this. So maybe 2 videos, maybe 3 videos. I don't want to rush you guys. I don't want you to feel overwhelmed. I was told we can move on with this because this is material you guys have been introduced to before. So we're going to do 6.1 and 6.2 this week. And then we're probably going to transition into chapter 11 or chapter 10. I think it's chapter 10. And then we'll do some of that because it's probability. So we're going to get started today on 6.1, which is law of sines. Your objectives are going to be able to use the law of sines to solve oblique triangles, to use the law of sines to solve, if possible, triangles, the triangle or triangles in the ambiguous case, to be able to find area of oblique triangles using the sine function, and then to solve applied problems. We're actually probably going to skip the applied problem just because without being in class, I'd really like you guys not to have to worry about that. As you're used to, we start out with some definitions. So an oblique triangle is a triangle that does not contain a right angle. So the part there does not contain a right angle. The oblique triangle has either 3 acute angles or 2 acute angles and 1 obtuse angle, which makes sense. So those are the only options if you're not having a right angle. The relationship among the sides and the angles of a right triangle are defined by the trigonometric functions are not valid for these triangles. So we can't use our traditional ones. Okay, if you need to pause it, feel free to get this down. I just want to make sure you guys are seeing this material. Okay, the law of sines. You guys have seen this before. So if A, B, and C, so capital letters, are angle measures of the triangle, and A, B, and C, lowercase letters, are the lengths of the side lengths opposite of those angles, then we have A over sine of capital A, so angle A, side length B over sine of angle B equals sine C over sine angle C. A lot of people have seen this in reverse. Either way works as long as you keep it. So I made a little note and said reciprocal also works. So the ratio of the lengths of sides of any of the triangles to the sine of the angle opposite, that side is the same. Let's try that again. That side is the same for all 3 sides of the triangles. I'm going to draw a couple triangles up top so you guys can see this. I don't know if you guys saw it on the other slide. So I'm going to go here, draw these out. There's a little space underneath that 1 or 2 acute spots. So this is angle A. That means this is side A. This is angle C. That means this is side C. This is angle B. That means this is side B. Same thing over here. C, little c, A, little a, capital B, little b. Okay. So again, you can pause it if you need to. Okay, solving an oblique triangle means finding the lengths of its sides and the measurements of its angles. The law of sines can be used to solve a triangle in which one side and 2 angles are known, or, so that's underline that, can be used to solve one side and 2 angles are known, or the triangle's known measurements can be abbreviated as side angle angle or angle side angle. So those are the ones we care about. So flashback to geometry days. Okay, so this one says solve a triangle with angle A equaling 64 degrees, angle C equaling 82 degrees, and side Z being 14 centimeters, and then round to the nearest tenth. So I'm a visual person. You guys are pretty used to this by now. I like to draw pictures. I don't know exactly what this triangle is going to look like, so I just drew a triangle. And then I'm going to label them A, B, C. If I know angle A is 64 degrees, and angle B, or angle C, is 82 degrees, we know the sum of the interior of a triangle is 180, so I can do 180 and subtract those two. 64 minus 82. When you put that into a phone, calculator, or whatever, I got 34 degrees. Double check my math. So you already see that this picture is not drawn accurately. But at least we know that. So I'm going to go down here. We know that angle A equals 64. Angle B equals 34. Angle C equals 82. And then side A, side B, side C. So for any of these type problems, I want you to solve all of it. Okay, and then we know the side length for side C is 14. So this is the one that really matters to us. We have to make sure that we're using that one, the C's, because we have the full thing given to us. So we know 14 over sine of 82 equals A over sine of angle A equals B. Oh, we know what angle A is. Silly Jenkins. 64 degrees. And then B over sine of 34 degrees. Okay. So to solve for A, you're going to use the two that have it's completely known and angle A. So I'm going to rewrite these as 14 over sine of 82 equals A over sine of 64. We're going to cross multiply. I end up with A equals sine. Oh, let's try that again. A times sine of 82 equals 14 sine of 64. Gotta get A by itself and divide both sides by sine of 82. Okay, so now when we do this, we're able to put this into our calculator at once. I know not all of you guys probably have your calculators at home. When I did this, I ended up with 12.7 centimeters for angle A, or side A. So I'm going to go over here, I'm going to fill that in. So it was at 12.7 centimeters. And then we want to find side B. So to find B, we're going to use that same 14 sine of 82 equals B sine of 34. We're going to cross multiply. B sine of 82 equals 14 times sine of 34. Divide by sine of 82. Okay, when I put this into my calculator, I ended up with 7.9 centimeters. And again, we're going to put that over here, 7.9 centimeters. If this was something we were doing in school, I'd give you 6 points just for the answers, and you just have to rewrite down the 3 that were given and then find the other 3, and then I'd give you points for the steps. So this probably would have been 6, 7, 8, 9, 10 points for this problem. Let me know if you have questions on it. Let's see if we can do the next one. Okay, so this one says solve triangle ABC if angle A is 40 and angle B, or angle C is 22.5. And then we know B is going to be 12. So this one I have a better guess what this picture should look like. I probably should have had it on the last one as well. But we're going to try it again. You guys have pictures made up on your slap papers if you guys are actually using the guided notes. But if not, then you can just use what I'm using. So A, I'm going to call this one C, and I'm going to call this one B. So this is 12. And then this one here is 40 degrees. This one here is 22.5. To find this angle B, remember we use 180. Subtract the two angles we have, 40 minus 22.5. When you put those into your calculator, I arrived at 117.5 degrees. So I'm going to start down here, the measure of angle A, 40, measure of angle B, 117.5, measure of angle C, 22.5, and then A, B, C, and then B's the only one we know is 12. So even though we define the measure of angle B, that's going to be the one we're going to have to use because it has the most complete information. So we have 12 over sine of 117.5 equals A over sine of 40 equals C over sine of 22.5. You're going to set up your two equations. So 12 over sine of 117.5 equals A over sine of 40. cross multiply. We get A equals, nope, I did it again. I was going to sing it to you. Ready? Oops, I did it again. Okay, I'll keep it there because this is going on YouTube. Equals 12 times sine of 40. Cross multiply here. We want to get that A by itself. Divide each side by sine of 117.5. Sine of 117.5. These two cancel. We end up with A equaling, it's approximately 8.7. So we're going to go over here. A is going to be 8.7. And then I can set my second one. 12 over sine of 117.5 equals C over sine of 22.5. It's the same situation. Cross multiply. So C times sine of 117.5 equals 12 times sine of 22.5. Divide by sine 117.5. Sine 117.5. These cancel. C equals, well, it's approximately. Put into your calculator. Double check to make sure when you're doing this that you're getting these same answers. So make sure you feel free to pause and double check because this still could be eligible to be seen before. Again, not before. That makes no sense. But we want to make sure you understand it because this is stuff you're going to be expected to know in certain math classes in college. Okay. So this is question number 2, example number 2. Pause if needed. Let me know if you have questions. Okay, on the guided notes, this would be the time where you guys would have another try it yourself, or your first try it yourself. Here we see our angle measures are 46 for angle A, angle C is 63, and we have a side length of C being 56. And it says solve the triangle. So we're going to substitute in what we know. We have A, ooh, it went away. And it won't let me go back. Let's see. Okay, well, it won't let me go back, so I'm going to rewrite all that out. Don't know exactly what I hit. So we have A equals 46 degrees, C equals 63 degrees, and little c equals 56 inches. Then we're creating that triangle just so I have a visual of this. Again, you don't have to. You might be better than I am at visualizing some of these. But I feel the need to make sure I can see it. So this is going to be 46. So this is going to be 63. To find this one, I do 180. Subtract the two angles I have. 63 minus 46. And that should give me 71 degrees. The side Z is 56 inches. You know that I'm going to create that little chart. Measure of angle A equals 46 degrees. Measure of angle B equals 71 degrees. Measure of angle C equals 63 degrees. A equals B equals C equals 56. Okay, and now we're going to create our fractions using that law of sines. So we have A over sine of 56 equals B over sine of 71 equals 56 over sine of 63. You got to use that C one, the C fraction, to be able to compare. I'm going to solve for A first. A sine 56. We're going to cross multiply. You end up with A times sine of 63 equals 56 times sine of 63. I wrote that backwards in here. That should be a 63. Got to get A by itself. Okay. I wrote things really backwards. Where did I go wrong? Let's go back. Okay, so my sine fraction, I wrote in a 56 instead of a 46. That's where it is. So let's go here, make this a 46. Okay, so you should be able to see it here. So that means on this one, this should be 56 over sine, then this one should be 46 down here. Okay, now that we corrected this, this should be fine. So you should have a sine of 63 equals 56 sine of 46. Got to get a by itself, divide by sine 63. Once again, these cancel. A equals, ooh. Fun fact, I also don't have my calculator at home. So let's see if I can get this to work on my cell phone. Okay. So here we have 46 sine times 56. So in my numerator, I have 40.2830 divided by sine of 63. 63 sine. That is 0.891006. Okay, so now I'm going to put this into my calculator. 40.2830 divided by 0.891006. And that gives me A to be approximately 45.21. Double check my math again, guys. I'm using a phone calculator. Okay, now let's do the B. Oh, I keep choosing the same colors. So B is going to be that same 56 over sine of 63 equals B over sine 71. I'm going to rope this off so I don't use it. So I end up with B sine of 63 equals 56 sine of 71. Divide each side by sine of 63. Okay, once again, I've got to do this in parts. So 71 times sine, times 56 gives me 52.9490. Okay, and then divided by 63 sine, that's going to be that 0.891006. Okay, now put it all in my calculator. 52.9490 divided by 0.891006. 59.4260. So 59.43 degrees. And we can look at this and see if this makes sense. Well, you know your biggest angle is B, so the biggest side should be side B. And we see that that holds true. Your smallest angle is A, so your smallest side should be angle A, or side A. So that seems to hold true. Okay, I'm going to pause. Okay, let's see if I can not clear this one. So again, you guys are given the information about angles. So we know angle A is 50, angle C is 33.5. Side length B is 76. So I can go ahead and fill those in. 50, 33.5, 76. I can find angle B the same way I've done the other ones. 180 minus 50 minus 33.5, which gives me 96.5. Okay, now we have a fraction that gives me enough information. So once again, I can create those. A over sine of 50. And then B is 76 over sine of, I lost it already, B 96.5. Which equals, and then C sine of 33.5. Okay. I'm going to use the first two here. I'm not going to rewrite them out and cross multiply. So A sine of 96.5 equals 76 sine of 50. Got to get a by itself, divide each side by 96.5. Okay. You know I'm back at it with my cell phone calculator. At least the iPhones have these capabilities, I guess. So it's supposed to say 50, but it looks a lot like 38 right now. So I'm going to rewrite that as 50. So 50, imply the sign, or input the sign, times 76. Okay, that gives me 58.219 divided by, and then it's 96 sine, 96.5 sine. Without having you guys to talk to, my voice keeps going. It's really weird. It's me just sitting in a room talking to myself all day. Sure look crazy. Okay, I arrived at A equaling 58.59577. So I'm going to round that to 58.6. And then for C, we're going to use the other two. Okay, we have C times sine of 96.5 equals 76 sine 33.5. Divide each side by sine 96.5. Okay. Once again, I gotta put all this into my calculator. So 33.5 sine times 76, which is going to be 41.9472 divided by 96.5 sine, which is 0.99357. I don't know why I had to put that in again. It's the same one from above. So 41.9473 divided by 0.99357 gave me 44.829. So 44.8. Again, we can check this. We see the biggest angle is at 90. Our biggest side is 76. Our smallest angle is C. Our smallest side is C. Okay, so that's all I'll make us do for today. Have a good day, guys. Bye.